Okay, this is our second vodcast in stoichiometry, and this vodcast is about how to work mass to mole stoichiometry problems. Okay, so our second type of stoichiometry problem is called a mass mole problem. Our first stoichiometry problem was a mole to mole. Now we're going to do mass mole. And in this particular problem, basically what you do is you start with a mass in grams, and what you want to do is you want to convert that to moles of a new substance. So in this process, okay, this is kind of the thought pattern that you should be going through. I'm going to start with mass of grams of some compound A. But what you have to remember is all the things that we talked about in the first podcast about the fact that coefficients in a balanced equation represent mole ratios and not mass ratios. So I'm going to have to take that grams of A, and I'm going to need it to convert it to moles of A. Okay? And then I can use a mole ratio to get moles of B. So how do I get something from grams of A into moles of A? Well, what you need to do is you need to take whatever your grams of A are, and you actually need to multiply that by our good old friend molar mass. Okay, so we want to multiply that by the molar mass of A. Okay, and when you do that, and if I set this up in my T box, okay, like we're going to do, I'm going to take the grams of some compound A. I'm going to multiply it by the molar mass, which means I'm going to put 1 mole of A up on top here, divided by however many grams there are of A in that particular mole. Okay? And if I do that, my unit right now would actually just be moles, and I'd have moles of A. And now I'm basically back to the problem I did yesterday. I want to then take moles of A and get that to moles of B. And to do that, what I'm going to do is I'm going to multiply by my mole ratio. Okay, and that mole ratio is going to be the mole ratio of compound B to compound A. Okay, and that mole ratio, again, comes from the coefficient from the balanced equation. So in my T box, I would take moles of B divided by moles of A. And now, as you can see, what happens is moles of A cancels out. And when all is said and done, that's going to give you moles of B. So really, all we are doing is we are adding one step that we've been doing for quite a while now. We've been doing this first step of taking grams of A times the molar mass a number of times this year. In fact, that was one of the first worksheets you did on the back of the last lab. So let's look at this following reaction, and let's actually do a problem here. So the fun part is I get to complete this reaction. So first of all, tell me what type of reaction it is, and go ahead and complete it. And you should be saying that it is a double replacement reaction. So in this double replacement reaction, I'm going to get Na going with the NO3. So I'm going to get sodium nitrate. And then I'm going to get lead iodide, PbI2. And if you want to go so far as to remember that that's aqueous, and that's going to be my precipitate, that's fine, but I'm not so much concerned about that at this particular point. And then you absolutely must make sure you go back and balance. So I'm just going to balance it for us real quick here. Okay, so now my problem is that I have 3.5 grams of sodium iodide, and I'm going to react that with excess lead nitrate. And that's important that we actually have the word excess in there, because what that's going to mean is just by having that word excess, I'm going to make sure I use up all of my sodium iodide, and I'm going to probably have some left over lead nitrate, okay? And what I want to know is how many moles of lead 2 iodide is produced, okay? So my mole ratio is actually going to be between the sodium iodide and the lead iodide. So what I'm going to do is I'm going to start with, in my tea box, 3.5 grams of NaI. And what I need to do is I need to change that to moles of NaI. So I'm going to need to multiply this by the molar mass of sodium iodide. So 1 mole of sodium iodide, okay, and if you don't remember, okay, we should do a little quick aside here, but we want to calculate the molar mass of sodium iodide, and sodium, if you recall, is 22.9 grams per mole, and iodine is 126.9 grams per mole. So adding those two up, I get 149.8 grams. Okay, now I don't want to stop here, but if I did stop here, my grams would cancel out and I'd be left with moles of sodium iodide. But what I want is moles of lead iodide, so I'm going to take this one step further and I'm going to multiply this by the mole ratio. And the mole ratio happens to be 1 to 2 because there's 1 mole of lead iodide to 2 moles of NaI. And I am just getting those from the coefficients. There's a 1 understood there and there's a 2 there. So those numbers are just coming from the balanced equation. And then I do my math and this comes out to be 0.011 moles of PbI2. And that's essentially a mass to mole problem. There's only one more step. So let's go ahead and look at another one. So I have the following reaction. Sodium chlorate is decomposed with heat. So like a good chemistry teacher, I'm making you write the equation. So go ahead and write the equation. Okay, so there's my reaction. That's the decomposition of sodium chlorate. And that's going to give me 2, 2, and 3 when I go ahead and balance that. Okay, so now the question is, how many moles of O2 will be produced from 15 grams of NaClO3? Okay, so my mole ratio is going to be between the Na, the sodium chlorate, and the O2. So there's my mole ratio, which is going to be, in this case, a 3 to 2 mole ratio. Okay, so again, what I want to do is, and I'm actually going to stop with and have you do a thought process here. I need to take this 15 grams of NaClO3, and what do I need to do with it? Well, what I need to do is I need to change it to moles. So I want to change this to moles of NaClO3, and then I want to change the moles of NaClO3 to moles of O2. Okay, so that's kind of the thought process that I want to go through. So going back to my tea box setup, I'm going to start with the 15 grams of sodium chlorate. Okay, and what I'm going to do with that is I'm going to multiply it by my molar mass, because that's how you get from grams to moles. So I'm going to multiply by molar mass. So I'm going to have 1 mole of NaClO3 here, all over the molar mass of 106.4 grams. Okay, and again, the way I got that 106.4 is the fact that Na is 22.9 grams per mole, chlorine is 35.5 grams per mole, and oxygen with 3 of them, each at 16, that gives me 48. So adding all that up gives me 106.4. So that's where I got that 106.4. It's the molar mass of sodium chlorate. Then, okay, that's going to get me the moles because now grams will cancel out. So again, if I stop here, I have moles. And what I want to do is get moles of oxygen. So I'm going to put my mole ratio in here. So 3 moles of O2 to 2 moles of NaClO3. Okay, and so now moles of NaClO3 actually cancels out. And so now you go ahead and you do the math and you get 0.211 moles of O2. Okay? And I got one more that we'll do together. So now, same type of process. How many moles of calcium nitrate are produced when 25 grams of aluminum nitrate, again, here's that fun word, reacts with excess calcium. So first thing I want you to do is, like always, go ahead and write the reaction. Okay, and the products of this reaction are CaNO3 2 plus Al. And you might have written the Al first, and that's fine. And then we want to balance this, so we're going to put a 3 and a 2 and a 3 and a 2. Okay, so there's my balanced equation. Okay, and now go ahead and work this out. Okay, now that you've had some time to work it out, I'm going to go ahead and show the work. We're starting with 25 grams of AlNO3, and I'm going to change that to moles. So I'm going to put 1 mole of AlNO3 to 212.9 grams. And again, that's just adding up all the elements in there. 1 aluminum, 3 nitrogens, 9 oxygens. That should be where that came from. And then we're going to do the mole ratio. And in this case, I want calcium nitrate, so my mole ratio is between those 2 critters. So I have 3 moles of calcium nitrate to 2 moles of aluminum nitrate. And my T-box, cross out, and do the math. And in this case, this ends up being 0.176 moles of CaNO3 2. Okay, one thing I want to point out before I stop here is as you look at this, notice how I write everything out. I have all the compounds, all the moles, I have everything all written out. And I did that on every single problem. I wrote out grams, moles of O2, moles. You should be doing the same thing. It keeps you from getting lost with what the heck does this number mean, or where did this number come from. You should write out the entire thing. Probably the biggest mistake that students make is if they do this the wrong way, and this is what I would consider doing this the wrong way. You put in 25, and then you put 1 over 212.9, and then 3 over 2. And then you wonder why you don't understand what anything means. You have no units in here, so how do I know what anything means? I'm just plugging and chugging and doing the math. Okay, you need to step up and know what you're writing down. So with this, okay, you should be able to complete worksheets 3 and 4.